Hi friends, welcome to our channel Decode with them. Friends, today we will discuss topic about signed and unsigned binary representation. Signed and unsigned binary number representation. Firstly, we will discuss about what is this signed and what is this unsigned binary representation. Normally, human will understand decimal number system. Example like plus 10, minus 5. When these values when we want to give this to one tool, like we want to send this decimal value to one mission like laptop. So through by using the ALU, it will converts this decimal number to binary number, like with zeros and ones, because the this machine will understand only zeros and ones. Here for plus we will take some binary values, and for minus we are considering some binary value. Then for positive, which what value we have to take, whether we have to take 0 or 1. For negative we have what we have to consider in binary, we will discuss about that. Firstly, we will discuss about what is unsigned binary representation. Here the name indicates that the unsigned binary means the for that number there is no sign for that. Example like in binary I am taking 101. For this there is no sign is there, whether it is positive or negative. But by default we are considering it is positive. This thing we are considering it is positive. The value we are taking, this totally we are considered as magnitude. It contains only magnitude. What is the value I am taking, that totally I am taking as magnitude, and by default I am taking sign as positive. This is the way we can represent. Here this 101, it is the for this there is no sign, so that we can represent this number in binary or octal or hexa or etc. It is possible in unsigned binary representation. And coming to the range, we can take range from 0 to 2 power n minus 1. Let's consider it is 3 bit. I am taking these bits 1 2 3 3 bits. 2 power 3, n means number of bits, it's 3. 2 power 3 minus 1. So 0 to 2 power 3 means 8. 8 minus 1, 7. The range for the 3 bit in unsigned binary representation is 0 to 7. Like this way we'll take the range for 3 bit in unsigned representation. Normally when we considering is all values are positive, it's fine, but for representing negative numbers is also important. In unsigned representation, negative value representation is not possible, only positive number representation is possible. To represent these negative numbers we are going for signed binary. This is unsigned binary, this is signed binary. This name indicates that it has sign, it may be positive sign or it may be negative sign also. Here for this number it contains two representations it is possible. This signed binary we can represent in two ways: signed magnitude form and complement form. Complement form is also two types are there: one's complement, two's complement. Now coming to the sign magnitude form, we will now I will discussing about sign magnitude form in signed binary. In sign magnitude form, it has both positive and negative numbers. Positive and negative numbers is possible, and it has two parts, sign bit and magnitude. In previously I'm taking one example like 101, and I'm taken total with magnitude. I'm considered total with magnitude in unsigned binary. But in signed binary, how we are taking is that the first digit what is there, we are considering this as sign bit. Remaining two bits I am considering as magnitude. For the previous thing, totally I am considering as magnitude 101. So this thing we can represent as, by default this 101 means total magnitude, it is 5. 101, 1, 2, 4. Which positions are here? Fourth position and 1. 4 plus 1, it's 5. By default we are considering plus. This value is plus 5. When we consider this in sign magnitude form, first one is represent sign and next one is magnitude. So what is this 1? 1 in sign, which it indicates this 1 I'm in sign I'm considered as negative. When it is this sign is 0 means I'm considered as positive. So this will be minus 1 means minus magnitude is 1. This is the way we can represent. When I am taking this value as 0, I am changing with sign is 0, then this total value will be 0 means negative, the 0 means positive. This magnitude 0 1 means 1. Like this way we can take. Like this way we can represent sign positive and negative representing in sign by, for plus I am taking 0, for minus I am taking 1. Now coming to the range. Here I am taking in previously I am also taking 3 bit. Here also I am taking 3 bit. 3 bit I am considering means 2 power n. N means 3. 3 minus 1, 2. 2 power 2 minus 1, 2. 2 power 2 minus 1. This will be minus 2 power 2, 4 minus 1, 3. Minus 3 to plus 3. This is the range for 3 bit in sign magnitude representation. For unsigned, that range is 0 to 7 for 3 bit. But sign, that will be minus 3 to plus 3. Like this way range will change for same 3 bit. Now coming to the drawback of sign magnitude form is that I am taking one example, plus 0 minus 0. For plus I am taking representation for plus as 0. For minus I am taking as sign as 1. And normally for this 0 I am considering magnitude as 0 0. Normally 2 zeros I am taking as magnitude. This here when you see that for plus 0 and minus 0, two representations is possible, 0 0 0, 1 1 1. But in real time there is only single 0 is there, plus 0 minus 0 is not there. For that we are expecting only single representation, but two representations is possible, different values we are getting. For plus 0 means 3 zeros, for plus 1 means 1 0 0. To avoid this, in sign magnitude we are going into ones complement. Whether in this ones complement method these two representations will be ignored and one representation is possible or not, we are checking. Now we are going for ones complement. Second one is ones complement. In ones complement, what we are doing is that we are only complementing the magnitude, but we are not complementing the sign. only when first we are taking the sign value, sign magnitude. That value we are just complementing. Example like plus 0 minus 0 is there. For plus I am considering as sign as 0. This magnitude I am taking as magnitude I am taking considered as normally 0 0 I am taken. For here also, for minus, what we can take, for minus we will take sign as 1, and remaining 2 bits what are there I am taking as 0. This representation we call it as, this representation we call it as sign magnitude representation form. This form we have to convert into ones complement. How we are doing is that I am taking 1 as common. This sign I am taking, I am not changing sign, just complementing the magnitude only. When I am complementing this to 0 0, we will get 1 1 complement of 0 means 0. I am complementing 0 with 1, 0 with 1. Now I am getting as this for ones method. For this, for positive plus 0 I am getting this, for negative I am getting this in ones complement. Here also two representations is possible, for plus 0 0 0 0, for minus 0 1 1 1. To avoid that, we are going for 2's complement and checking whether single representation for 0 is possible or not. And next point is that in one's complement, for positive I am taking sign magnitude. Means when we are taking the positive, when I am taking the positive with some value, what is the sign magnitude value is there, same value we will get here. Where for here we are checking 0 0 0, same value we are getting for sign magnitude. In sign magnitude also, for plus 0 3 zeros we are getting, here also for plus 0 3 zeros we are getting. That's why we are taking that for positive, any positive value is there and we want to do ones complement. For that, what is the sign magnitude value is there, that value we will get. For negative value we have to do 2's complement. When we are seeing the, for negative is there, when I want to do ones complement, for that means we have to take sign magnitude and keeping this sign as common, and remaining 2 digits what are there, that thing we are complementing. This is the ones complement process. Here for negative values we are doing ones complement, for positive values are there means what is the sign value for that positive value, what is the, we are taking common directly, not here. See, what is the positive value for sign magnitude, this value we can take blindly, that thing only I am written here. Next, coming to the range. Here same as sign magnitude, this range is, I am taking 3 bit means this range is from minus 3 to plus 3 when I am taking 3 bit. In ones complement also same. Next, going for the 2's complement. Here 2's complement also same. For positive value I am taking sign magnitude, when the positive plus 5 are there, like a plus 5 is there, what is the sign magnitude value is there for positive 5, same value we can take here. When it is negative means we have to do 2's complement. Here I am doing writing here. This is the flow we have to follow. In 2's complement, what we are doing is that 1's complement plus 1 we are adding. What is the 1's complement value we are getting? That for that I am adding 1. Then that will be considered as 2's complement. How means? First we will check whether 2 representations is possible or not. I am taking plus 0 and I am taking minus 0. For plus it is 0. For zeros I am taking common 0. Here same sign magnitude. What is sign magnitude? 1's complement, 2's complement, same. For positive, same values we will get. For negative only we are doing 2's complement. Here we are getting negative. Negative means that indicates negative, that indicates 1. And the values, what are the 0 I am taking common 2. This will represent sign magnitude. For these values I am doing 1's complement. When I am doing 1's complement means I am taking common sign and complementing the 2 digits. That will be 1 1. 0 means 1, 0 means 1. This is 1's complement. For this I am adding 1. Then that will be 2's complement. So I am adding 1 here. By adding 1, 1 1 0 1, that means 1 1 0 1 1 1 0 and 1. Here the 3 bits only there. I am 3 bits I am adding, for the 3 bits I am adding plus 1. So I am taking only 3 bits and remaining carry I am ignoring. Here when we observe means for sign to 1's complement we are taking sign as common. We are not toggling complementing. But when we want to do 2's complement we have to include this sign also. Normally normal flow is that we have to stop here only. For 1 1 1 1 means 0 1, 1 1 means 0 1, and we should not take the carry to the next sign, but we are taking sign. Sign also we are including and taking that carry to the next sign. That is the difference in sign in 2's complement. For 2's complement we have to take sign plus magnitude. Both we have to consider when we are doing 2's complement. Here when we checking, when we see this, for plus 0 we are getting 0 0 0. For minus 0 in 2's complement, in minus 0 we are in 2's complement, this 2's complement, that will be in also 0 0 0. Two same values we are getting, means for 0 single representation is possible, that is 0 0 0. That's why we are preferring 2's complement. In this type, next coming to the range. Coming to this range, that will be, let's consider in previously we were talking about 3 bit. I am taking 3 bit means 2 power minus 2, 3 minus 1 2, 2 power 2 2, 2 power 2 minus 1. That will be minus 4 2 plus 3. That is the range. Here 1 bit is increasing because for 0 single representation is possible. For negative 0 representation is not there. So that's why single bit, extra bit is added in the range. That's the difference in 2's complement. In mostly in sign representation, 1's 2's, here we can see that sign magnitude form, 1's complement, 2's complement. These 3 methods are there. Within this we are preferring 2's complement. 2's complement. Why? Because single representation is possible. for 0. That is the main reason why we are considering the 2's complement rather than 1's and sign magnitude. And second is that by following the 2's complement, it is efficient. It will be accurate. We are getting an accurate result. We will get. That's the second advantage in 2's when that's why we are in within this we are preferring 2's complement. And coming to the disadvantages, this designing of 2's complement, it is bit difficult rather than 1's and sign, because when we want 2's means first we have to convert into sign magnitude. From sign magnitude we have to convert into 1's complement. From this 1's complement we have to add 1, so that then it will be converted into 2's complement. So designing of circuit will be increase for 2's complement. But in most of the computers, for doing subtraction we are considering 2's complement. Why we are taking this? The main advantage in unsigned binary in signed binary representation is that for when I want to add 2 bits means it's plus 5 plus 5. So this single adder is plus adder is sufficient. When I want to do subtraction, here again for plus minus 5 minus 5, again one subtractor is required. Instead of doing this by using this complement methods, I am taking single adder. For this I am taking plus 5, and next one is that minus 5 is there. This value I am doing 2's complement because we are preferring the 2's complement method. Then that value will be converted into positive. That value I am passing to here by using single. Here the main, by using this 2's complement with single operator, single addition operator, we can perform any arithmetic operations. Instead of using this 2 adder and subtractor, by using single adder with the 2's complement we can do addition and subtraction is possible. Then by using this, reduction of hardware will be improved by using 2's complement. Rather than designing the one adder and one subtractor in separately, instead of that I am taking only single adder and converting the negative value by using 2's complement to positive. So by using single adder, addition and subtractions is possible. That is the advantage for signed binary number representation. And that's it. If you like my video, please subscribe to my channel and share your comments regarding my video, how I am explaining. And thank you for your love and support.